Okie dokie, Calc. Today we're talking about derivatives. So Calc section. This is going to go along with the sections in my book. Um, Here's my book in case you're curious. I use this Calculus of Single Variable book. It looks like that. That's it. Okay. So section 2.1. This is like basics of a derivative. So what a derivative. First, I'm going to go over. So derivatives. Okay. I think I spelled it right. So it solves the tangent line problem. And so I'm going to talk, I've already talked about kind of what that is, but just like a recap. I don't even need that. I have a curve. And what is the slope of the curve at that line, or the tangent line? And to get that, we're going to use the derivative. And so we call it the difference quotient. And when you see the equation, you're going to be like, it makes sense why it has that name. It can also be called like the definition of a derivative. I've seen it called that as well. So either or, they're the same thing. And so basically, what I have written in my paper is this. So f of c plus delta x, boop, minus, this is where the difference part comes in. I'm looking for a different colored pen. Give me a second. Sorry, this is really unprofessional, but this minus right here, that's important. Minus f of a, or f of c, all over delta x. Also in my notebook, I have it written as the limit delta x approaches 0. F of c plus delta x minus f of c over delta x. And I'm going to look at it in a second what that really means. The way I wrote it when you use it is f of x, f of x plus delta x minus f of x all over delta x. Okay, that's what it really is. And I'm going to look for an example. Okay, also some derivative notation. I'll cover that at the end. Check-in time, 3 minutes. Okay. So what does this mean? So if this is point C, then this right here, so this would be, so this point right here would be C, comma, f of c, right? And this point would be c plus delta x in our x position. And then for the y, we would have f of c plus delta x, right? Because we're moving x here and we're moving x here, right? So this gets us, so the f of c plus delta x minus the f of delta x on top, or minus the f of, oops, let me do that again. So the f of c plus delta x minus the f of c, the top part, gives us the change in y, or the delta y. And then the bottom is just delta x. So c minus c plus x, delta x, those cancel out in the denominator. So it's really change in y over the change in x, which equals, change in x, which equals the slope. And so as c gets arbitrarily close, we can get the slope at that one line. That's kind of what's going on. And so here, the slope's going to be more flat, kind of like that. Here it's going to be more steep. So the derivative is showing us the slope of this line as it changes. And then what we can do from this is get an equation, and the equation shows us the slope of that line at any point. And then some derivative notation to be aware of. So f prime of x, dy dx, and then d over dx, they all mean the same thing if you're doing this process. So in the next episode, and tomorrow I'll go over how to do one of these, and then we'll get into where this gets really easy. Hope that was helpful.